Okay, so now we will see regarding time period. Okay, finding time period of a process. So while finding time period, generally the process is okay. First we will apply all the forces. Okay, apply all the forces on the body. Generally, to find time period, what we do? We will apply all the forces on the body. Mg, any if minus kx is there, all the forces will be marking. Okay, so first thing is apply all forces. Okay, after that, from this we should identify restoring force. So many forces will be there. From there we should be able to find restoring force. Maybe just for understanding this, I will show you one example. Suppose if a mass is here and if this angle is theta, this is going to be what? Mg. Now this is tension T. If we resolve, we will be getting, this is going to be T cos theta and this is going to be T sin theta. Now suppose if we resolve this Mg, if theta, okay, this is going to be Mg cos theta, and if we draw this component, this is going to be Mg. Now in this I have marked all the forces. But this Mg sin theta is what is responsible for bringing this bob back to the mean position. So I will be interested only in what? Mg sin theta. So apply all the forces, then after that we should be in a position to identify which is the restoring force. Okay, after that we know acceleration is equal to minus omega square x. Now what we need to do? We should apply A is equal to Fm form. Whatever force is available, we should make into acceleration. After that, compare this. Compare is equal to 2 pi by omega. Okay, after comparing the right hand side of this one and whatever, just roughly I have written F by m. Whatever restoring force we are finding, we should put here Fr divided by m. So after equating omega square x into and this one, we should find T is equal to 2 pi by omega. Okay, so this is the general way to find the time period. Okay, so this may come in electrostatics, this can come in oscillation, this can come in fluid mechanics, anywhere this can come. Clear or what? Right. So here you need not resolve this, okay? We don't need it actually. This tension will be balanced with mg cos theta. So here we are not going to do anything with the t cos theta and t sin theta, so that let's just leave it like that. Okay, now we will proceed with this simple pendulum itself. We will see the time period of this simple pendulum using this method. Then we will pendulum. So here restoring force is Fr is equal to what? Mg. Restoring force is mg sin theta. Now we have considered this in simple harmonic motion just because this displacement is going to be very small. That is the reason we have considered this in simple harmonic motion. This displacement is very small. So here sin theta is very small. Okay, and we can say sin theta is equal to, suppose if we consider this displacement as x, then by hypotenuse we can write this as x by L. X by L. So here restoring force is going to be mg into x L. Okay, can we put a negative also there? Because it is restoring force. Okay, its direction is opposite to the displacement. We can put a negative here. Okay, right? Now we will replace this, we will equate this with the general equation of force, and we will what? General equation of force means the equation of acceleration for simple harmonic motion. Okay, so we will equate with that and we will be able to find the answer. Okay, so here A is equal to what? Fr divided by m. So A is equal to minus mg x by L divided by m. So m will be cancelled off. We will be getting A is equal to minus g into x by L. Now we will take the general equation of simple harmonic motion. A is equal to minus omega square. This is the general equation of what? General equation of acceleration. So can we equate this and this? Okay, so let this be 1, this be 2. So equating 1 and 2, we will be getting minus omega square x is equal to minus g into x by L. This x will be cancelled, negative will be cancelled. This is going to be omega is equal to root of g by L. Now this is going to be 2 pi by t is equal to root of g by l, and finally we will be getting t is equal to 2 pi into root of l by g. So whatever method we have used here, same method we can apply anywhere. Okay, apply the forces, find the restoring force, find acceleration, equate that acceleration into minus omega square into x, then find the time period. Okay, clear? Clear? Shall I erase this? Okay, so now t is equal to 2 pi into root of L by G. This is the time period of simple pendulum. Now we will consider some cases for this one. Suppose if we increase the temperature, what will happen to the length of this wire? We have seen a similar case in elasticity also, remember? Thermal stress and thermal strain. Okay, so just like in the case of resistance, R is equal to R naught into 1 plus alpha delta theta, what will happen if you increase the temperature? The length will become L naught into 1 plus alpha delta theta. Okay, so this is going to be the new length. Clear? Now we need to substitute there and we need to find the change in time period. Okay, so now the corresponding time period, suppose if this is t dash, okay, the corresponding time period when we increase the temperature, there is increase in length, so that corresponding time period is t dash. So t dash divided by t is equal to what? 2 pi g, everything will get cancelled off. So this is root of what? L by L naught. This is the previous length, this is the new length. Okay, now when we write, this will become L naught into 1 plus alpha delta theta divided by L naught into root. This is what will come after cancelling everything. So this L naught will be cancelled off. What we will be getting? T dash by t is equal to 1 plus alpha delta theta into 1 raised to 1 by 2. Clear? So based on this, we can expect so many varieties of question: gain in time, loss in time, change in the percentage change in the time period. All this can come. Percentage change. With the percentage change we can do. Okay, so please remember this. We will revisit this when we start thermal properties of matter. Okay, we will revisit this topic when we start thermal properties of matter again. There I will spend some time here. Okay. Okay, done. Now, so this is one case. Okay, when we increase the temperature, if we need to know the time period, plus alpha delta theta raised to 1 by 2 into T, all these things can come. Now, second point is, suppose if we keep this simple pendulum in a water or in a liquid, what will happen? Okay, so okay, if it is like this, then mg will be acting at the same time. Upthrust also will be there, correct? So we need to consider the apparent weight. So apparent G also will come, effective G also will change, right? So mg dash, this is what is the apparent weight. This is equal to mg minus upthrust. Okay. Correct? So this of the pendulum, density of the pendulum into G dash. Okay, so this is the mass, volume of the density of the pendulum into G dash. This is equal to volume of the pendulum, density of the pendulum, volume of the pendulum, density of the liquid into G. Correct? Just verify the formula. Is it correct? Right. So I can put G dash is equal to G minus V rho L G divided O into pendulum, raw pendulum. Correct? I just divided with the V in. So full, this is fully immersed, half fully immersed, half we will do that change, you know that. Okay, so now G dash became G minus rho L by rho pendulum into G. Okay, it is important. G, it became G minus density of the liquid by density of the bob into general GH. Now we will put in the general equation. T is equal to 2 pi into root of L by N G dash. We can put T is equal to 2 pi into root of L by G minus the ratio of liquid, ratio of pendulum into G. Bus, over. Okay. So in the G dash value, this will increase or decrease. Density of liquid is less than density of pendulum. So any chinna value vandalum kuda G dash is equal to G minus something. So idu vandu inga denominator la thane varum. So modala it was 2 pi into root of L by G. இப்போ என்னாச்சு g dash decreased என்ன ஆகும் time period will increase. Okay, so that's what time period will increase. Now, if this is a simple mass, suppose if we keep a simple mass in electric field, will that mass experience a force? Chumma oru mass, will it experience any force? It will not experience any force because it is neutral. Ini solla pona, if this is a conductor, what can happen? All the negative charges will come to this side, positive charges will go to that side. So andha madri, so adu vandu JEE mains illana advanced and the discussion konjam varum. So for us the thing is here konjam electric field basics plus simple harmonic motion oscillation testing of this is what will come. So what we should understand is this is a simple mass, no force, but what we do, we will be putting a charged mass. We will be putting a charged mass and its charge is going to be how much? Q. Now if positive charges are kept like this, what will happen? Electric field will be acting in this direction. So what will be the force? The force experienced by this mass is how much? In upward direction, QE divided by M, correct? QE divided by M. Force is QE. Acceleration will be QE divided by M. So let us show only force, no worries. So force is going to be QE. So what will happen? The time period was 2 pi into root of L G. It was L by G. Now this time what will happen? Since it is acting in the upward direction, we will have to subtract that also, G minus QE by M. So this will be the time period in case. Suppose if the bob is, if the simple pendulum, if it is of negative charge, If it is of negative charge, the force will be in which direction? F is equal to QE will be in the downward direction. Okay, so apply those changes also. Q is equal to 2 pi into root of L divided by G plus QE divided by M. Suppose here the electric field direction is in the opposite direction. So associatively you will have to make the changes here. Okay, please be careful. Okay, simple thing, simple logic. Please look at the direction of the force, direction of the acceleration, and make the necessary changes. The force experienced by a charge, Nitish, force, if we keep a charge in electric field. Electric field means, suppose if we keep a charge, there will be an electric field because of that charge, just like a gravitational field. Okay, gravitational field because of mass. Because of, if we keep a mass, okay, if we keep another mass here, there will be an attraction. Same way, okay, mass I have threw away. Now I kept a charge there. Now instead of mass, if I keep another charge, if it is plus, it will repel. If this is minus, it will attract. Okay, so a charge, if we keep like this, a force will be applied on this, but this will experience a force. That force is nothing but F is equal to Q into electric field. Q into electric field. Clear? You will study this in +2. Right. Okay, children. So time period is equal to 2 pi into root of G plus QE by M, or sometimes it is going to be G minus QE by M. Clear or what? Okay. Right. So which case? Third case. Okay. Fourth case. Pendulum in lift, same case of laws of motion, same case which we have discussed in which chapter? Gravitation. Fluids also we have discussed. Same logic here. Suppose if the lift is going up, if this is going up, okay, so if it is moving up, then time period is going to be 2 pi into root of L by, what is G effective now? G plus A. G plus A. If it is coming down, then T is equal to 2 pi into root of L by G minus A. Yes. Okay, now here in this case, if A is equal to G, and if this lift is coming down, then what is the time period? T is equal to 2 pi into root of L by what? G minus G. So this is going to be 0. So we will be getting time period as infinity, means no oscillation. Okay, so if it is coming down with acceleration due to gravity, the simple pendulum will not oscillate. Then Shall I erase this? Copy it. So suppose if we this in the lift, actually this is moving up, coming down. Suppose if the simple pendulum is in a body which is moving with a horizontal acceleration. Now the problem with this case is we will be easily able to solve this. First thing which we need to understand is we cannot apply Newton's laws of motion directly here, because this is an accelerating body. Okay, if we are, this is a non-inertial frame. Okay, pseudo force and all you have studied, right? Okay, so this is accelerating. So in order to make it like an inertial frame, what we will be doing, we will be adding an acceleration in this direction also. If we do this, then things will be easy. Okay, so if that, then in this direction there is an acceleration in this direction also, correct or what? So we need to find the resultant acceleration to the what, to the formula. So resultant acceleration is what? If when they are vectors, root of g square plus a square. Okay, they are in perpendicular direction. This is a, this is g, correct? So resultant acceleration, if we need to find this is going to be root of a square plus g square. Okay, so that we will put in the formula. Suppose if this is theta, this is going to be root of a square plus g square acceleration, and time period is going to be 2 pi into root of L by or root, you can put. Clear? Okay, suppose if a car is moving around, okay, if a car is moving around, see why I am integrating all this, directly you will be able to apply this and get the answer. Okay, otherwise you will have to think a lot and you will have to apply the laws of motion concepts. For some children it will be easy, for some they will feel that question. So if I give this as points, then it will be easy for you. So suppose if the pendulum is kept inside a car, it is moving around with a constant speed v, and that is radius is r. Okay, so what will happen? All these things are easy, just like that case. Only change here it is, there is going to be a centripetal acceleration. So acceleration due to gravity and centripetal acceleration is there. We will take the resultant and put in the same formula. Okay, so everything is easy, just apply the simple concepts. So this is going to be t is equal to 2 pi in root of L divided by what? T square plus what is centripetal acceleration, children? V square by r. Okay, so r the whole root. Okay, the resultant acceleration we are taking. If you have any doubt in this, please ask. Okay, see, last one is seconds pendulum. So seconds pendulum is nothing but the time period is going to be 2 seconds. It is going to be 2 seconds. So already we know the time period. So this is equal to 2 pi into root of L divided by 9 Earth. Okay, so if you solve this, we will be getting the length of the seconds pendulum as around 99.3 centimeter in Earth. Okay, in Earth's surface, this is going to be around 99.3 centimeters seconds pendulum. So here only thing is, sometimes they may ask like what is the length of seconds pendulum in moon or in some other planet where acceleration due to gravity is half of the Earth, something like that. For that purpose only I give. Clear? Okay, so now you go to that not handouts in this time period of the one where the temperature is increased. Okay, so there you can write this one, the gain or loss in time. You can add this also, gain or loss in time. Okay, is delta t. Okay, is equal to delta t. Okay, in that you can write this also, the change in time period to the original time period is actually approximately, okay, 1 by 2 alpha delta theta. Okay, mark this also. Okay, in detail we will discuss this in thermal properties also. For the time being, you can take this. Okay, change in time by original time is equal to 1 by 2 alpha delta theta. Okay, so in this, gain or loss in time is nothing but delta t. Okay, time period into 1 by 2 alpha delta theta means you will be getting loss or gain in time. Okay, so all these points are enough to deal the problems under this category. Okay, let them put the pendulum anywhere, we will deal it. Okay, clear? Hand out polama. By 15. Okay. Okay, so we have completed the basics and time period of just simple pendulum. Tomorrow we will finish the problems related to this. Then we will see spring pendulum also. Spring pendulum also we will keep everywhere. Okay, not like this. Okay, because spring pendulum will not be affected much because that is m by k. M will not change, no. Mass will not change whether we keep. So this much varieties will not come, but spring will play. Okay, but parallel, that is easy. So that also we'll see. Then we'll finish the problems and we'll wind up this chapter. Okay, so you have to sit patiently, no, because how much points we'll be getting, easily, comfortably we will be able to solve the problems. Correct or what? Otherwise you will have to spend some time to understand all this. Right? Okay, if you have any doubt you can ask. Okay, so we have seen various cases of simple pendulum yesterday. So adil vandu innoru case kuda enna, suppose if a car is coming down an inclined plane and if this pendulum is attached on the roof of the car. So if it is coming down the inclined plane, the time period is going to be t is equal to 2 pi into root of L by g cos theta. Suppose if this is the inclined plane, if this is theta, the car, it is coming. Here there is a simple pendulum. Okay, so this will have g will be acting in this direction. This is going to be g cos theta and this is going to be g sin theta. We are interested in the perpendicular component. Okay, we are interested in the perpendicular component. So suppose someone come down. No need to ask. Okay, just keep on coming. So this will be singing like this. Since the car is moving, car will be moving under the influence of its own force, g sin theta, everything will be there. Okay, so we should be interested in this g cos theta. So put that g cos theta there in the regular equation. Okay, so that is one more point. Note this point also along with the points we have added for simple pendulum. Then now we will start doing the problems related to it. Okay. So we'll continue doing problems on that. Question number 40 then next. Question number 40. Okay, question number 40. Okay, read. Question number 40, the problems associated with the simple pendulum. Right, a clock which keeps correct time at 20 degrees Celsius is subjected to 40 degrees Celsius. Okay, it works at 20 degrees Celsius. Now we have given a temperature and its temperature, we have given heat and its temperature is increased to 40 degrees Celsius. If the coefficient of linear expansion, this is nothing but, see, a regular equation is, the time period regular equation is equal to 2 pi into root of L by G. Now if will happen, G sin theta, G cos theta. This is attached to the roof of the car. You will have to replace this G with G cos theta. That is the only difference that is going to come here. Okay, come back to question number 40. So here, if the coefficient of linear expansion of pendulum is 12 into 10 raised to minus 6, how much will it gain or lose in time? So yesterday we have written a formula, right? Delta T by T is equal to 1 by 2 alpha delta theta. So this is actually fractional change in time period. Delta T by T is nothing but fractional change in time period. Delta T is the change in time period, whether it is loss or gain. Correct? If we increase the temperature, length will increase. If we decrease the temperature, length will decrease. Right. So solve this. So a regular time period is given or not? 86? Correct. So what we can do, delta T, this is the loss or gain time, is equal to T into 1 by 2 alpha delta theta. So what is the regular time period? 2 pi into root of L by G. So a clock which keeps correct time at 20 degrees Celsius. So what should be the time period of clock? How much it should oscillate per day? Hmm. 24 into 60 into 60. So remember that value. Okay, 86,400. Correct, Dana? 86,400, right? So that will be the time period for a clock. Correct? Clock on the okay. So this value is the time period, the time taken what for 1 day. How many seconds it is going to do? So here we can do 86,400 into 1 by 2 into what is alpha? 12 into 10 power minus 6 into delta theta is 20. Whether it is Kelvin or degree Celsius, difference is going to be same. Okay. So calculate this. We will be getting 10.3 seconds per day. Okay, so if it is temperature sensitive, if that material is temperature sensitive, the time will be wrong. Correct or what? Just like the resistance we have seen. Resistance should not change if it goes to some other place. The material should be such a way that it should not change actually. So such kind of material we will be selecting. Okay, leave it. What the question, Palama? Clear? Understood all of you? Question number 41. If you know all those points, this discussion will be easy. Okay. The magnetic bob of simple pendulum has a relative density rho. Okay, so this is the relative density of the bob. Okay, the time period of this pendulum is t. If the metallic bob is immersed in water, the new time period will be. Okay, so what is the formula? Can you say? T is equal to rho into G. So this is the formula. Okay, now what is different here? Just take only density alone. Okay, take the density part alone from the formula and solve this. Okay, whatever is changing, that alone consider. Length change aguma? Length will not change. So this is constant, this is constant, this is constant. Okay, so whatever required, it do like this. T divided by T dash is equal to what we should write. Okay, so reduce into that and solve it simply. What answer varudhu? Okay, so this is going to be, now we will simplify this. This is going to be actually 2 pi into divide density of the bob into G minus density of the liquid into G. This density of bob will go here. Okay, I can take this G out. Okay, so T is equal to 2 pi root L by G. Root of L by G, and then this is going to be density of the pendulum divided by density of the pendulum minus of the liquid. So this entire term is what? Constant. Correct? Now T by T dash is equal to N. What will come here? Simply L by G, nothing will come here. So can I write this is going to be density of the bob minus density of liquid divided by density of the bob? Okay, so from this we can find the new time period we need to find. So new time period is T dash is equal to T into root of okay, which option pa? D. Yes. Okay. Any worries? Go through the solution.
Restoring force acceleration only, then
in the case
நீங்க எக்ஸ்பிளைன் பண்ணிட்டு இருந்தீங்க.
inclined plane.
ஃபர்ஸ்ட் ஒன் இது restoring force.
G
G sin theta தான சார் restoring force. அப்ப அதோட acceleration
you have tried to derive full or இல்ல இப்போ வந்து just இது swing ஆகிறது G sin theta நால, that is the thought. G sin theta நால இப்படி force இருக்கலாம். Restoring force na the force responsible to come back. அது வந்து 2 pi into root of L by G cos theta answer வரணும்னா we should put the entire thing. இப்படி யோசிச்சா we will not get the answer. கம்ப்ளீட்டா போட்டுட்டு full force எல்லாம் போட்டு if we derive then we will get.
அப்ப வந்து restoring force வந்து friction எடுக்கணுமா இல்ல G sin theta எடுக்கணுமா?
Friction இருந்தா மட்டும்தான். Friction நம்ம இங்க we don't consider friction here.
Friction இருந்தா தானே.
We'll do one thing. You want the derivation of that thing? Okay, I will try that and send to you. Just next week, இன்னைக்கு இல்ல, from tomorrow onwards, remain being between. ஒரு 2-3 வாட்டி. Okay pa, good getting. We'll go to the next one. So next question is question number 42. I'll be giving so many cases end of the chapter. நிறைய cases இருக்கு. எர்த், ஒரு chord, through the diameter எல்லாமே. ஸோ அது இருக்கும். If you want to see the derivation, ஒரு அந்த மாதிரி ஒரு 6-7 cases இருக்குது. We'll see. I won't be deriving it today. Simply I will be giving the results and all. Okay. What is the next question, pa? Question number 42. Yes. What is that? The period of simple pendulum is doubled when the length is its length is made 4 times. See then direct question. Okay, leave it. Okay, question number 43. The period of simple pendulum is doubled if the length is made 4 times. Okay, next one. A simple pendulum is executing SHM with time period T. If the length of the pendulum is increased by 21%, the percentage increase in the time period of pendulum is. Okay, understood? The time period of simple pendulum is T. The corresponding length will be L. What they are asking is, if the length of the pendulum is increased by 21%, means L dash is equal to, see children, L plus 21% is increased. So 21 divided by 100 into L. So 21% க்கு என்ன சொல்லலாம்? 1.21 L ன்னு டைரக்டா எழுதிடலாம். L dash is equal to 50% na 1.5 L அந்த மாதிரி. ஓகே, ஜஸ்ட் புரியுதுங்களா? முகேஷ் புரியல? புரிஞ்சுது? கரெக்டாப்பா? 50% na 100%, அதுதான் 1. 100% 1, 50% 0.5, 25% 0.25, 21% 0.21 அந்த மாதிரி. So this is length. இப்போ என்ன கேட்குறாங்க? Then percentage increase in the time period of the pendulum. So I could say T2 by T1. So 2 pi G, everything is same. What I am going to write? This is equal to L2 divided by L1, L2 divided by L1. So I can write this is going to be 1.21. So what is this actually? 1.1. So T2 is equal to 1.1 T1. So how change இருக்கும்? 10% change. இது எப்படி எடுத்தீங்களோ how we have written this one, same way we can take this also, right? So 10% change. And one more thing is there. I think you might have studied in the initial chapters. The root irundhuchuna 1/2 into 21%. How much we are getting? 10.5. 10.5. Small difference will be there, but that is also fine.
Error analysis here.
Condition കുഴപ്പമില്ല, ചെറിയ വ്യത്യാസം ഉണ്ടാവും. Question അതായോ വായിച്ചതാ. See, in using error analysis also you can do this. Just 1/2 into whatever is there in the percentage, you will be getting the answer. The thing is, if big difference is there, very big difference is there, for this one we are getting 0.5 difference. See what we are doing. This is nothing but if T is proportional to root. So if this has got X percentage length, then T will have what? 1/2 into X percentage change. This is what? Now if we come to this case, the change in time period is going to be how much? 1/2 into 21%, we are getting 10.5. This is accurate value. 10%. This is nothing but 10 points. So for small difference, 21%, 0.5 error is there. So as the percentage increases, percentage level increases like 100%, 200%, 150%, obviously the error will increase. Clear or what? For small values and all you can use, no worries. For big values, if based on the options, if the option has big difference, no worries. Okay, since error analysis also not a shortcut, error analysis is a conceptual method. So obviously if they want us to calculate like this, options will have small difference. If error analysis is fine, there will be some marginal difference in the options. Okay, next one, next question. Question number 44. So momentum, kinetic energy, same thing. Correct or what? What is the relation between momentum and kinetic energy when there is root? 2me. P is equal to root 2me. So in that case also, percentage change in momentum will be given. What is the percentage change in the kinetic energy will be same way, same method. Clear? Okay, right. Question number 44. So question number 44, the length of the simple pendulum is increased by 1%, then its time period will increase by how much? So percentage increase equal to what? 1 by 2 into what is the change in time period? What is the change in the length of the simple pendulum? Into 1. So this is 0.5 percentage. Getting the same method, this method we have applied here. So 21 percentage L dash is equal to 1.21. Here 1.01 children. இங்க தெரியாம 1.1 போட்டேன்னு வச்சுங்க, இந்த ஹரிபரி ஆன்சர் will go wrong. புரியுதுங்களா? அதான் ப்ராப்ளம். இது மட்டும் கொஞ்சம் கவனிச்சா போதும். Direct method also you can do. Okay, this is going to be 1.01. Okay, so அப்படி போடும்போது what will be the answer we will be getting? What will be the answer we will be getting? We'll see this also. T2 divided by T1 is equal to what? Root of 1.01. 1.01. When you take the root of this, how to take the root of this? So always go with this thing for small values. Okay, always go with this method for small values. Okay, if you take the root of this, I think 1.004 or something will be getting. So percentage change is going to be how much we are getting? 5%, 1.004 T1 will be getting. So 5% change we can take like that. Okay, now next question pa. Yes, the bob of a simple pendulum, question number 45. Question number 45. Question number 45. The bob of a simple pendulum of mass m and total energy E will have maximum linear momentum equal to this is a question from work power energy itself, right? The bob of a simple pendulum of mass m and total energy will have maximum linear momentum what? Root 2 me. Okay, so E is equal to P square by 2m. So P is equal to root 2me. avladhan bas. Option B. Question number 46. Question number 46. The mass and diameter of a planet is twice that of Earth. Okay, the mass and diameter of a planet is twice that of Earth. The period of oscillation of pendulum on this planet will be, if it is a seconds pendulum on Earth. Okay, so T is equal to 2 pi into root of L by G. Okay, so inga vandu L is constant, 2 pi everything is constant, and time period, if this is a seconds pendulum, so this is going to be 2. Okay, so diameter and mass are twice. So what is the formula for Gm by R square? So in that planet, how much will be the g dash? G into 2m divided by radius will become half double. So 4r square. Correct? So we will be getting this as g by 2. G by 2. So fine. So what will be the answer? So t dash, this is nothing but what? 2 seconds. So t dash by 2 seconds is equal to what? Root of idu mele pogum g divided by g by 2. So t dash is going to be 2 root 2. Option B. Clear? So take this time period. This is actually the time period if the length of the pendulum is comparable to the radius of Earth. Okay, if length of pendulum is compared radius is getting doubled, right? Radius is getting doubled. Radius is getting doubled. Diameter is getting doubled. So radius get doubled. Over simple pendulum. Okay, so mark this also. Okay. Okay, so this is the general same formula alone, the same formula only thing is if this length is very less compared to the radius, this 1 by L, what will happen to 1 by L? 1 by L will become very much greater than 1 by R. Correct or what? If the length of the length of the pendulum is very much less than radius R, what will happen? 1 by L, here denominator is less, this is going to be very much greater than 1 by R, here denominator is huge value. So what will happen? This formula will take the regular form of root of L by G. Correct then? So only if this length is comparable to the radius of R, radius of Earth, then only we need to use this formula. Okay, so that is also there. Fine. Okay, now we will discuss spring pendulum. Okay. directly we can take from the force law. From the force law directly we can take. Already from the force law we have written like T is equal to 2 pi into root of m by k. F is equal to what? Minus m omega square x. Okay, using that already we had written this. Okay, so this k is what? Force constant, but in this case this can be what? Spring constant. Correct or what? Now mass of the spring, if the spring and mass of the block connected to the spring, mass of the block connected to the spring. So if we keep like this, or even if we keep like this, will there be any change in the mass? Or if I keep like this, will there be any change in the mass? No. Will there be any change in K? K is spring constant. So if the spring is very rigid and strong, K will be more. If the spring is very soft, K will be less. That is the idea and plan of the manufacturer of the spring. Manufacturer, how he is going to make the spring, based on that only K will be. Okay, if the length of the spring, if we change the length, elongation kadayadu, not elongation, length of the spring, if we extend the full spring, how much is the length? So K depends on that one, not on elongation. So you might have seen K is inversely proportional to L. This length is the original length of the spring, not this length. If this spring this length is what is this? Correct or what? புரியுதுங்களா? புரிஞ்சுச்சுன்னா எப்படி தலையாட்டணும்? இப்படி தலையாட்டணும் சிரிச்சுட்டு. இப்படி புரிஞ்சுதா? இப்படி தலையாட்டணும் யாருன்னெல்லாம் சொல்ல மாட்டேன். அப்படி தலையாட்டணும் அவ்வளோதான். இந்த டஸ்ட் அதெல்லாம் அப்படியே இதெல்லாம் சம வெயிட் தான். புரிஞ்சுதா? Okay, so this is what okay, so in all these cases this is the time period. Okay, clear? Okay, note it down. So we could say that a clock based on spring pendulum gives same time everywhere. Even if we keep on hill or some other planet, wherever we keep, this is going to give us the exact timing, because this does not depend on the length and acceleration due to gravity. So that is one point. Shall I erase this? அழிச்சிடலாமா? So if we get a mass m1, mass m2, and this is k, okay, so in when we need to take the time period, t is equal to 2 pi into root of m by k, we need to take the mass of the combination. Mass of the combination is not m1 plus m2, we say this is going to be reduced mass, m by k. So this reduced mass is nothing but m1 m2 divided by m1 plus m2. I am not going to derivation of all this, okay, but remember this and apply. Okay, clear? So that one, 2, 3 cases were over previously. Consider this as the 4th case, this as the 5th case. We keep two masses m1 and m2. In this case actually two masses will be moving, two masses will be oscillating, correct? But in this case this will not oscillate. This will not oscillate, but this one will oscillate. So we just need to consider only this mass. So root of 2 pi into root of m1 by k. See children, when we put this in vertical way, the thing is like in horizontal, if it is horizontal, if this is the mean position, if this is the mean position, if this is say for example 2 meter, if we hang it vertically, because of this weight of this mass, because of the weight of this mass, this will extend a little. Okay, so that is nothing but, suppose if we take x naught, if this is mean position is 2 meter, if we disturb this, doing simple harmonic motion, when we hang like this, it will extend a little, and the mean position, say if this is 3 meters, say for example if this is going to be just like a 3.5 meter. So in this case what will happen, it will hang a little bit more, extend a little bit more, and from here if we do a disturbance, ding 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 ding. Understood or what? Will do simple harmonic motion with a different mean position. It will be doing oscillation but a different mean position. Okay. Now if we equate the force mg, and what is this, children? Kx naught the bodlama, just considering magnitude. Okay. Now if I write mg is equal to kx naught, I can write what is the formula? T is equal to 2 pi into root of m by k. So I can write m by k is equal to what? X naught by g. So if this data is given, using this data also we have the liberty to find what? X naught by g. Using x naught by g also we can find the time period, but make sure, keep it in mind that still this time period is not directly dependent on g. Formula wise it is coming, just like a Young's modulus we write stress by strain, but Young's modulus is the property of the material. Same way we should have an understanding that just you can use this formula doesn't mean that it depends on x naught and g. புரியுதுங்களா? Suppose in this, அதுக்கு என்ன simple example என்ன, in the spring just keep it horizontal, ding dung 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 dung, what time period you will be getting? 2 pi into root of m by k. This result, same result you will be getting. Clear or what? Okay, write it with the pakka clarity in the mind. So என்ன பண்ணணும், அதுக்கு கீழே here you should write if possible in red ink. Okay, time period is independent of g. இதுக்கு கீழே எழுதிடுங்க. Okay. Okay, done. Right, so here we will be applying some external force. So the force acting on, suppose if this is K1, this is K2, if the spring is soft, it will extend a little bit. See children, the force acting on this spring series combination, now the trick is the force will be same. Okay, displacement will be how much? Suppose if this has got a displacement x1, okay, if this got a displacement x1, this has a displacement x2, now total displacement is going to be x1 plus x2. Force will be F. this will be same as minus K2 x2. Okay, force on both the springs will be same. So என்ன எழுதலாம்? x1 is equal to minus F by K1 and x2 is equal to what? Minus F by K2. Okay, now externally one force we are applying, no? Okay, so that force same everywhere. So we can say that here F divided by K equivalent is equal to enna edhulam? Okay, this is also what? Minus F dane, restoring force la. So I can put minus F. So minus F by K equivalent is equal to minus F by K1 plus minus F by K2. So 1 by K equivalent is equal to what? 1 by K1 plus 1 by K2. Okay, so this is the spring combination if we put parallel. Okay, series. Okay, so if we need to find K equivalent, this is going to K2, K2. So this one completed. Erase பண்ணலாமா? This is not stringent. If you want, you can put 2 mass also, no problem, but make sure the displacement must be same. Okay, so here force is same. Okay, force will be same. Restoring force is going to be same in all the springs. Okay, series combination. But here why I am putting 1 mass? Because here what displacement is same. Displacement is same. Okay, Jansi ஏதோ ஒரு டவுட் இருக்குதுன்னு. டவுட் இல்லை, என்னமோ இப்படி டவுட் நீங்கள் பறந்து வருது. உங்களுக்கு டவுட் இல்லை, அப்போ வேற விஷாகா இல்லை உங்கள்கிட்ட இருந்து டவுட் இப்படி வந்துட்டு இப்படி பறந்துருக்குமோ? டவுட் இல்லை? Okay, see, thing is, see, look at this children. If this is K1, this is K2. This is K1, this is K2. Okay, இது ரெண்டு பசங்க, ரெண்டு குழந்தைகள், கிண்டர் கார்டன் சில்ட்ரன். ஓகே, எல்கேஜி படிச்சுட்டு இருக்குது. இவன் சரியான வம்பு, குறும்பு பையன். இந்த பையன் பரவாயில்ல. சரி, அப்போ டீச்சர் என்ன ரெண்டு பேரையும் பிடிச்சிட்டு இப்படி வலிச்சிட்டு இருக்கு. இந்த பையன் என்ன, டீச்சர் நான் வர மாட்டேன்னு சொல்லிட்டு அழுதுட்டு இருக்கு. ஸோ இந்த பையன் இப்படி பிடிச்சிட்டு இருக்கும்போதே டீச்சர் இஸ் giving some extra force and doing what? Making sure that both of them are pulled together. அந்த மாதிரி. Okay, you will be thinking like we are applying a force here. If this spring constant is more, definitely a distortion like this or this should happen. No, we are making sure that it is moved combinedly. That is what is parallel. அப்படிதான் அதோட what கரெக்டான explanation. புரியுதுங்களா? Now this one, suppose if here one spring, one mass is kept here, another spring is connected like this. If this is K1, again this is K2, this is mass. What about this? This is also parallel combination. Why this is parallel combination? Because here also displacement is going to be same. When we pull this mass to this side, when we push this mass to this side, compression wise this will have a displacement. This side elongation wise this also will have the same displacement. திருப்பி இப்படி பண்ணும்போது here compression will be same, there expansion will be same. Restoring force ஓட direction எப்படி இருக்கும்? Here restoring force direction will be upwards, here restoring force direction will be this side. இங்க if we are pulling this one here, if we are pulling this one here, F external, what will be the restoring force of this? I am applying. What will the spring do? This will be applying force in this direction. The force, restoring force of spring 1 will be in this direction. I am pushing. What does this spring? When I am pushing that side, he will be opposing layer. So here also this spring is also applying the force in the same direction. Here also restoring force is same direction. Restoring force same direction. Restoring force same direction. Displacement is same. Displacement is same. Displacement is same. So நம்மளோட ரெசிஸ்டர் சொல்ற மாதிரி இப்படி இருந்தாலும் இப்படி இருந்தாலும் இப்படி இருந்தாலும் இப்படி இருந்தாலும் if they are connected to the same terminals, they are parallel, same way, same force, same direction of force, same displacement. That is parallel combination. Clear or what? Okay, correct? Okay, so F is equal to what? F1 plus F2. Okay, so K equivalent into X. KX then K equivalent to X minus போடலாம் நம்ம நிம்மதிக்காக. Actually K1 into X1 தானே? X1 K1 into X1 X plus minus what? X, correct? Okay, எல்லாம் cancel ஆகும்போது K equivalent is equal to what? K1 plus K2. Okay, so for parallel combination, capacitor மாதிரி. Okay, just like a capacitors. Okay, done. Okay, any doubt in this? Shall we raise? See children, suppose if we have a spring constant K and its length is L. If we divided this into two halves, this is L by 2, this is again L by 2. So actually the spring constant K is inversely proportional to the length, the original length of the spring, actually length of the wire. Okay, so if we divide this into 2, the spring constants will become 2K, 2K. Clear? Same way. Okay, so if we divide, if this is K, if we divide this into so many springs, okay, 1, 2, N, what will happen to the constants? NK, NK, NK. Correct or what? Same way, Tirpi. If we have some spring, if we have joined them together, that will become 2K, 3K, NK. Okay, so if we divided this into, if this is L, this is L by N, L by N, L by N. Appadina NK, NK, NK. Same way, this is going to be NL, NL, suppose constants will change. Clear or what? If we get a ratio 1:2, 2:3, 1:2, okay, 3 ratio 1:2:3, what we should do? We should take the length, divide by, suppose see, in the madri 1:2, 2:3. Length is divided into 1:2:3. Okay, length was there, this length is divided into L1, L2, L3 is divided into 1:2:3. Then what we should do? L divide by 1 plus 2 plus 3, 6, into this one. If we do, what we are getting? L by 6. So its corresponding K is going to be 6K. Same way, take, this is going to be L1. L2 eppadi? L divide by 6, adallathukume same, into its part is how much? 2. So this is going to be what? L by 3 le? So this is going to be 3K. Adhe madri we should adjust it. Okay, suppose L3 is equal to L divided by 6 into its ratio is 3. So this is going to be L by 2. So its corresponding spring constant is going to be 2K. Okay, fraction vanda, just put the reciprocal. Okay children, comfortable? Okay, done. So shall I erase this? So time period of spring pendulum is 2 pi into root of m divided by k. Suppose simple points. If we are dividing the spring into n parts, spring into n parts, okay, we are dividing the spring into n parts. So each part will have how much spring constant? Each part will have nk, because this is going to be L by n, okay, so this is going to be what? Nk, right? Now what will be the time period if we make simple spring pendulum with each part? T dash is equal to, with respect to t, what should I write? Root n. Kile mele. So that is t by root n. Okay. Root n. If you are dividing a spring into n parts, the corresponding time period is nothing but t by root n. Okay. Okay, so many small springs combined together, we got NL, that is nothing but k by n. So 2 pi into m by k by n root will come. So this is nothing but t dash is equal to root n into t. Practice problems related to this so that you can save time. At least if you are able to save 30 seconds from 10 questions. 30 seconds from 10 questions. How much you are getting? 5 minutes. In that 5 minutes, if you are able to do 7 questions, how much mark difference will be there? 7 questions. 7 into 4. 28 marks. So 28 marks rank difference will be there. So huge difference will be there. So you should be very precise. Easy questions, try to do taking time 5 seconds to 10 seconds. Okay, simple questions are earlier coming, right? Last year and before also, simple questions only they are asking. So try to improve the speed and accuracy also. Okay, so this small things. Okay. Third thing, a spring cut into n parts. Cut into n parts. So if I cut into n parts, what will happen to the k? This will become nk. Now again, connecting this in parallel. Connecting in parallel is just like the resistance in series. So nk plus nk plus nk is what is going to happen. So nk plus nk plus nk, this is what is going to happen. So the k dash is going to be what? N square k. Correct? If you are dividing the spring into n equal parts and connecting them in parallel, then what? N square k. T dash will become 2 pi into root of m divided by what? N square k, right? So this is nothing but T dash is equal to T by N. Clear, children? Okay, one more point I will give, just 2 more points. After that we will do problems. Okay, then with all these points we will be able to deal. If we cut the spring, okay, if we cut the spring into 2 pieces of lengths in the ratio L1 is to L2. This is a spring. We cut them into 2 pieces. So here the length is L1, here the length is L2. Okay. Then the spring constants of these two. K1 is equal to L1 plus L2 divided by L1 into K. K2 is equal to L1 plus L2, this is L1, divided by L2 into K. So you may have better methods also. I have shown you how to do with the ratios. It's your wish. Whichever method you are comfortable with, you can follow. So this is going to be the spring constants. Suppose if the number of lengths are N1 and N2, number of turns are also given, means number of turns are N1 and N2. Say first spring, a spring is there that we cut into 2 parts. First ring is of turn N1, second ring is of turn N2. So in this case, K1 is equal to N1 plus N2 divided by N1 into K. Just same formula, but only change is here it is number of turns, and K2 is going to be N1 plus N2 divided by N2 into K. Okay, boss. Okay, done. So come which problem? Next one. 46. Yes. Problem number 46. 40. Okay, 47 now. Okay, 47. Question number 47. A spring of force constant K is cut into 2 pieces such that one piece is double the length of the other. Okay, this is cut into 2 pieces. If this is L, this is 2L. Okay, what they are, the long piece will have a force constant of, the long piece will have a force constant of how much? Correct or what? Which one? 3 by, can we use this one? Which formula? Force constant of which one they are asking? Force constant of long piece. So K is equal to L1 plus L2 divided by L1 into K. So if this is K2, if we need to find, then this is K1. So L, that is 2L, we can keep 2L plus L divided by 2L into K. Correct or what? So what pa? 3 by 2 K. Over, matter over. So option B. Directly thinking also you can do, but unnecessary confusion can be avoided if we use this formula. I felt like this is helpful. So you have the liberty to use your own methods. Okay, please think and do. Next question. Two bodies M and N of equal masses are suspended from two separate massless springs of force constants K1 and K2 respectively. If the two bodies oscillate vertically such that their maximum velocities are equal, the ratio of their amplitudes. Okay, so question number 48. So maximum velocities are same. So A1 omega 1 is equal to what? A2 omega 2. And what is omega? Root of K by M. So K1 by M, equal masses. And this is going to be A2 into root of K2 by M. Correct or what? Okay, so the ratio of amplitude, okay, A1 to A2 is equal to what? Root K2 by K1. So which option? C. Correct? C, D. Root is, okay, option D. Okay, so this is amplitude. Clear? Any doubt, children? We'll move to next one. Question number 49. Two identical springs of constant K are connected in series and parallel as shown in the figure. A mass M is suspended from them. The ratio of their frequencies of vertical oscillation will be. So if T is equal to 2 pi into root of M by K, frequency is equal to 1 by T, correct? 1 by 2 pi into root of K by M. See, we can say frequency is directly proportional to root A. So if we connect in series, if we connect in series, then K series is what? K by 2, right? And K 2. So what they are asking? Ratio of their frequencies. So frequencies in series and frequencies in parallel is equal to what? Root of K by 2 divided by 2K. So what we will be getting? 1 by 4, 1 by 2 will be getting. Option C. Any doubt in this? Shall we move to so in the points related to all this where I have given, you need to add one more point. We have assumed all the springs were massless spring. We haven't considered mass of the spring. Suppose if we get mass of the spring also, okay, say for example capital M, you just add this point also there with the knot. Suppose if the spring, okay, spring mass is capital M and another mass, block mass, is small m. If it is given like that, then we need to take the effective mass. So mass effective is equal to nothing, simply this mass m plus, you can take the mass of the spring divided by 3. Remaining all the things are same. Okay, so a derivation is there. Through derivation we will be getting. So you can remember this. Small m, mass of the block plus 1 by 3 of the mass of the spring. Then remaining things are same. 2 pi into root of m by k. So in this case, the time period will become what? Same thing. Everything is remaining things are same. 2 pi into mass effective divided by k. Frequency will become what? 1 by 2 pi into root of k divided by m effective. Only that change we need to do, nothing else. Done? Now we will move to another question. Question number 50. யாருமே தூங்க, எல்லாரும் கவனமா இருந்துட்டு இருக்கு. கதை பேச முடியாது. ஸ்டூடெண்ட்ஸ் எல்லாம் ரொம்ப இன்ட்ரெஸ்டிங், பயங்கர அக்கறையோடு படிச்சுட்ருக்கு. இப்படி ஸ்டூடெண்ட்ஸ் எல்லாமே சீரியஸாக இருக்கும்போது நம்ம எப்படி கதை சொல்ல முடியும்? எனக்கு 2 வார்த்தை கொஞ்சம் சிட்சாட் எல்லாம் பண்ணுன்னு இருக்குது. பயமாக இருக்கா நான் பார்த்தா. ஸ்ப்ரிங் மாஸ் சிம்பிள் பெண்டுலம், சிம்பிள் பெண்டுலத்துக்குள்ள ஸ்ப்ரிங்கும் மாஸும் போட்டேன் எப்படி இருக்கும்? செம்ம ஆராய்ச்சி. ஸ்ப்ரிங்குக்குள்ள ஸ்ப்ரிங்கு தொங்க விட்டுட்டு அதுக்குள்ள ஒரு சிம்பிள் பெண்டுலம் போட்டால் எப்படி? அப்படியெல்லாம் போட்டு பார்க்கலாமா? ஐயோ, ஈவினிங் டவுட்டாக வரும். இன்றைக்கி எப்படியாவது டயர்ட் பண்ணிட்டு விடணும். நேற்று உங்களை டயர்ட் பண்ணி எப்படியாவது பண்ணலான்னு பார்த்தா நான் போனால் நான் செம்ம டயர்ட். எனக்கு அதனால் மீட்டிங்லலாம் வர முடியாது. உங்கள் மேலே பழி வாங்கலாம்னு நினச்சிட்டு என்னால் முடியல. ஒரு சில ஸ்டூடெண்ட்ஸ் இப்போ ட்ரக்ஸ் எடுத்துகிட்டு இருக்காங்க டவுட்டு. கிளாஸ்லையும் இருக்கும், மீட்டிங்லையும் இருக்கும். எப்படி எப்படி முடியும்னு தெரியல. யாரை பற்றி நல்லா சொல்ல மாட்டேன், சும்மா ஸ்கைஸுக்கு என்ன போலீஸ் ஷாட் மாதிரி. நம்மளும் என்ன நினைக்கும், கொஞ்சம் தூங்கி கொஞ்சம் ஓய்வு எடுத்துச்சுன்னா நமக்கு கொஞ்சம் நிம்மதி கிடைக்கும்னு நினைச்சா ட்ரக்ஸ் எடுத்துருக்கா என்ன, கொக்கைன், ப்ரௌன் சுகர். ஓகே, Continue பண்ணலாமா? பண்ணலாமா? Okay. Question number 50. A block of mass m attached to spring of spring constant k oscillates on a smooth horizontal table. No friction. Okay. ஒரு டேபிளுக்குள்ள அது விளையாடிட்டு இருக்கு. The other end of the spring is fixed to a wall. The block has a speed v when the spring is at its natural length, mean position. Before coming to the instantaneous rest, if the block moves a distance x from the mean position, then okay, enna ketirukku displacement they are asking, correct? Then displacement is equal to, so nothing, enna at mean position it will have energy half mv square. So if you look at the option, they are asking what? Displacement only. Okay, so half mv square is the kinetic energy. So potential energy will be converted into kinetic energy, correct? Half k x square. Okay, only that much. So அவ்வளோதான். So mass cancel பண்ண முடியாது, இருக்கட்டும். Half will be cancelled. So x is equal to what? M by k into v square. So x is equal to v into root m by k. So C, option C, nothing else. Okay, done. Next question. A block is placed on a frictionless horizontal table. The mass of the block is m. Question number 51. Question number 51. A block is placed on a frictionless horizontal table. The mass of the block is m. Spring of force constant k1, k2 are attached on either side. If the block is displaced a little and left to oscillate, the angular frequency of the oscillation will be. So அது என்ன combination pa? Parallel combination. Okay, ரெண்டு spring, one mass is there, two springs on the both sides. Okay, அவ்வளவுதான். So this is parallel combination. What they are asking? Angular frequency. Angular frequency means omega, 2 pi by t. So t is equal to what? 2 pi into root of m by k. So this is parallel combination means k1 plus k2. K1 plus k2. So what we can do? 2 pi will be cancelled off. This is going to be root of k1 plus k2 divided by m. Correct dane? So option A. Option A. That is what? If you know those simple points, then we can do this. Another question. Question number 52. Question number 52. So this is nothing but this is parallel combination. Okay, parallel combination. Question number 52. A particle of mass 200 gram execute SHM. The restoring force is provided by spring of force constant 80 Newton per meter. The time period of oscillation. Okay, option A. Direct question. Option A. Question number 53. 2 pi into root of m by k. Do the direct substitution, get the answer. Correct then? 51. Direct. A. Another question polama. Question number 53. Okay, anyone has any worries? Any doubt? Okay. Question number 50. A length is the length of spring is L. Okay, length of spring is L. Force constant K. When a weight W is suspended from it, if its length increases by x, okay, elongation. If the spring is cut into two equal parts, and put in parallel, the same weight is suspended from them, the extension will be. Okay, so F is equal to what? Kx. So we can say x is inversely proportional to k. What they are asking? The primary discussion is about the extension. Correct or what? The primary discussion is about extension. So x is the inversely proportional to k. What happens if you put them in parallel? If you cut into how many pieces? 2 parts. Cut into 2 parts and then in parallel, then we have seen this is nothing but n square into k. N square into k. So here it is nothing but 2 square into k, so 4k. So if the first displacement is x1 and if the second displacement is x2, then the extension is going to be 4k for x2 and this is k for x1. What they are asking? x2. So x2 is going to be x1 by 4. According to the question, x by 4. What is the answer? D. A mass is suspended from a string of length L and force constant K. Okay, a mass is suspended from a spring of length L, force constant K. The frequency of vibration of mass is F1. The spring is cut into 2 parts and same mass is suspended from one of the parts. The new frequency is going to be F2. So when it is cut into 2 equal parts, this is spring constant becomes 2k, right? Frequency of vibration is F2. So which of the following is the relation between F1 and F2 then? Okay, so T is inversely proportional to root k. Correct? So enna pannalam? F is directly proportional to k. Correct thane? So F1 by F2 is equal to k by 2k. Idu correct appa? Idu correct ah? Avladane. So enna F1 is equal to F2 by root 2. Okay, F2 by root 2. N option? B. F2 is equal to okay. F2 is equal to root 2 F1 D la. Okay, done. முடிஞ்சுதா? Questions முடிஞ்சுதா? அவ்வளவுதானா? சரி, நான் உங்களை விடுறேன் பிளான் இல்லை. விட்டே வச்சுக்கோ, டவுட்டாக ஓடிட்டு வருவாங்க. ஸோ அதனால் அதுக்கு ஒரு கேப்பே கொடுக்கக்கூடாது. டவுட் கேட்குறதுக்கு கேப்பே கொடுக்கக்கூடாது. கிளாஸ்லேயே உட்கார வச்சுட்டு ஓகே. இப்போ வந்து we have seen only simple pendulum and spring pendulum. Okay, gravitation, அதே மாதிரி fluid mechanics, electrostatics. Okay, எல்லா இடங்களிலும் வந்து what is there are scopes for simple harmonic motion. So wherever simple harmonic motion is there, okay, everything is attached to this chapter. நீங்கள் dipole, magnetic dipole போட்டுட்டு if you twist it, that will do what? Ding, 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 ding. Okay, if there is no damping, illana, there is no friction, it will do simple harmonic motion. If you, this is water, water kulla floating body is there. If you do what? Then that also will do simple harmonic motion if you take out viscosity. So in the mari lot of cases are there. So I will give maximum some number of cases without derivation. I will be telling the case and the formula. If we keep a hemisphere ball, okay, hemisphere ball, from one end if you keep a small ball, it will do come this side, that also will do simple harmonic motion. So almost all the formulae are similar. Small changes will be there. So for some cases, that alone we will have to remember. Remaining all the things, the structure will be almost same. So we will see that also. Then what else is there? Different types of oscillations are there. That is natural oscillation, and we don't consider friction. When we consider friction, we will come. Damping factor means sound wave. Okay, what happened? It has come down. புரியுதுங்களா? got the idea, right? இது எல்லாமே போறது just ஒரு செகண்ட்ல புரியுதுதான். ஓகே, நீங்க என்ன சார் சேர்த்துடாதீங்க. ஓகே, a damping. Okay, யாரு பிரபா சார் சவுண்ட் கேட்கல, மைக் போடுங்க. மைக் போட்டுட்டு ஜஸ்ட் கிவ் a boost, okay, or given a force. அப்போ என்ன ஆகும்? it has got a force. ஸோ இதே மாதிரி என்னெல்லாம் இருக்குது? Natural oscillation is there, damping is there, damped oscillation is there, forced oscillation is also there. So in all those cases, these formulas இதெல்லாமே படிக்க வேண்டியதில்லை. Displacement மட்டும் கொஞ்சம் பார்த்து வச்சிங்கன்னா small changes are there for displacement. Amplitude வந்து that time it is not constant amplitude. So all these cases we will see today. Okay, அது முடிச்சதுக்கு அப்புறம் chapter will be over. Clear or what? So now we will see different time periods of various cases.